We are here with Evelyn and Finn.
Hi! Hi!
And we are going to show you how to make circuit clay. We are going to start off by building a basic circuit. For this experiment, you will need clay or Play-Doh, an LED light, and a battery pack. Take a small amount of clay or Play-Doh. We will be using Play-Doh for our experiments. Roll the Play-Doh into 2 small balls and place them in front of you. Look at the wires, or legs, on your LED. One leg is a little longer. This is the positive leg. The shorter leg is the negative leg. Gently split the legs so that they're angled outwards. It's really important to remember which leg of your LED is the negative and which is the positive when placing the legs inside your clay or Play-Doh. Your battery case has 2 wires. The red wire is positive and the black wire is negative. Stick the end of the red wire into the clay or Play-Doh that has your long LED leg. That's the positive leg. And then stick the black wire into your other clay or Play-Doh that has the shorter leg. That's the negative leg. Switch the battery case to on and watch the LED light up. You've just created a circuit.
When mine's working, that one's not.
Evelyn, switch the wires. Put the red on the other side. There you go. You just added in the wrong Play-Doh. We just built a basic circuit. But what is a circuit? A circuit is a loop that allows an electric current to flow through it. The circuit that we just built has 4 basic parts. Electrons. These are the invisible particles that carry around the energy from the battery. LED. When the electric current passes through the LED, the electrons release some of the energy they picked up from the battery. The LED changes that energy into light. Battery. The battery provides energy to the electrons. After the electrons release some of their energy, they return to the battery for more. Electrons travel in only one direction. They always flow from the negative end of the battery to the positive end. Wires and Play-Doh. The wires in the Play-Doh allow your electrons to travel through the electric circuit. You'll use the wires in the Play-Doh to connect the parts of your circuit together. What is a short circuit? Remember how we said a circuit was like a loop? Think of a short circuit as a shortcut. Though electrons are good at carrying energy and an electric current, they're kind of lazy. They'll take the shortest path around the circuit and skip anything that makes them work, such as lighting up an LED. What happens when they touch? Touch them, make them touch.
Turns off.
It turns off. By touching the Play-Doh together in your basic circuit, you've made a way for the electrons to flow through the circuit without going through the LED. Okay, so we created a circuit and now your LED lights are lit up. And what happens when we push them together?
It lights up.
When you have your Play-Doh touching, what happens to the light? It turns off. Now we're going to show you how insulating clay works. What you'll need: your basic circuit and white insulating clay. First, let's recap what happens when our Play-Doh touches. By touching the Play-Doh together, you've created a short circuit. A short circuit happens when you make another path that's easier for the electric current to travel through. Now we're going to take a small ball of insulating white clay, flatten it to make a disc. Put the white disc in between your Play-Doh. Press them all together and watch what happens. How does the white insulating clay work? The white insulating clay does not allow an electric current to flow through it. When you've added the insulating clay to your short circuit that you made with your Play-Doh, it blocks the shortcut through the Play-Doh. Without the shortcut, the electrons have no choice but to go through the LED and light it up as they flow through the circuit loop.
Let's turn off the light and see if this glows in the dark.
Circuit Snail. The first thing you want to do is create the body of your snail. Using your white modeling clay, flatten out a piece and place it on the body of your snail. Have it take up roughly 90% of the top surface.
Is this a smoke?
It's a snail. That's good.
Is it a snail?
It's not a snail yet, because what does a snail need? A shell. We have to make the shell.
This is it.
Okay. Now it's time to make the shell. We're going to start off by rolling our Play-Doh nice and thin, and then we're going to twirl it just like a cinnamon bun. Once we're done making the shell, we will place it on top of our white modeling clay. Now it's time to add the eyes to our snail. We'll need 2 LED lights for the eyes. When placing the LED lights on the snail, we want to make sure that both positive legs, that's the long one, goes into the body of the snail, and the negative legs, that's the smaller one, goes into the shell of the snail. It's time to hook up our battery pack. So we want to make sure our red wire, that's our positive wire, goes into the body of our snail, and the black wire, that's our negative wire, goes into the shell of the snail. If everything is done correctly, when you flick that switch to the on position, the LED lights will light up. For this experiment, you will need orange clay, white insulating clay, 4 LEDs, and a paper star. Using the orange Play-Doh, roll out 2 thick snakes. Using the white modeling clay, roll out another long, thick snake, the same length as the orange. Split the legs of the LEDs to make V's, with the positive legs at the top and the negative legs at the bottom. Press 4 LEDs into the white modeling clay and smooth the clay over the legs to hide the slits. Press the orange snake onto the bottom of the white strip, covering the negative legs. press the other orange snake onto the top of the white modeling clay. Attach the battery pack by sticking the red wire onto the top orange layer and the black wire onto the bottom orange layer. I will admit, it did take us a few tries to get this one to work.
Listen, it's doing that. Wow! Thanks for watching. Bye.
If you enjoyed this video and want to see more just like it, please like and subscribe.
Okay, I'm tired.